Hi everyone, my name is Clay, Staff Software Engineer at OpenC3, and today I'll be showcasing how to connect the Arduino Sensor Kit to Cosmos. So what is Cosmos? Cosmos from OpenC3 is a suite of applications that controls embedded systems. We can connect and control anything from test equipment to power supplies, power strips, to development boards like Arduinos and Raspberry Pis, and of course our bread and butter, satellites. Cosmos is the software of integration, test, and operations, helping to bring all of your hardware together. Cosmos is also open source and publicly hosted on GitHub, so anyone can quickly integrate with it at any time. So today we are working with the Arduino Sensor Kit. And inside we have the large sensor kit here with a variety of sensors. And for today's demonstration, we'll be working with the BMP280 barometric air pressure sensor right here. We're going to connect the air pressure sensor right here to the I2C channel right here. And finally, we'll be connecting the USB connection from our computer into our Arduino. We see that it's powered on and we are good to go. You can learn all about the BMP280 sensor as well as all the other sensors that this kit comes with on the official Arduino Sensor Kit website. This makes it very easy for us to integrate. It has all the different sensors with the wiring already ready and just needs to plug in into your Arduino Uno and all your sensors are ready to go. Great, and once you have your Arduino plugged in, you can go ahead and open the Arduino IDE, either the offline or online version. Right here I have the offline version. The Arduinos actually give us quite a lot of examples code. So if you were to open the Arduino examples sensor kit code, and if you open the pressure sensor code, this actually has a wonderful starting point for a significant amount of information that's necessary for our demo today. Primarily it's this pressure.read temperature, pressure.read pressure, and pressure.read altitude. Those are going to be the three measurements that we're going to be able to get from our barometric sensor for today. So then we take a look at here in the code. Very simply, we have our setup code. We go ahead and open up our serial port and we start looking at our code. We set our baud rate at 9600, which is just the default here. And then we have a loop. Effectively, what we're doing here is we grab the three measurements, the temperature, pressure, and altitude. These are going to be floats. These are going to be regular 4-byte, 32-bit amounts of data. And what we're going to do today is we're going to actually construct our packets. So that's kind of the way that Cosmos will be reading the data is through these telemetry packets. And we'll just say that each packet is going to be 13 bytes of data total. Each of these floating points are going to require 4 bytes, so we have 3 times 4 of those, as well as 1 byte for the packet ID, just so that Cosmos has a way to know exactly which packet ID this is. So we construct our array packet to have 13 bytes of data, and then we go ahead and add our first packet ID is going to be our BMP280 ID, which I just set to 1, just so that we have a number that Cosmos can rely on to know exactly what we know which packet this is. And then down here, what we're doing effectively is we are converting the floats that we are receiving into bytes so that we can actually convert it into our packet and send it out to Cosmos. So what this will do is the Arduino is little endian, so it's setting up our byte stream so that it's reading from the lowest byte first and then adding that data in. And finally, we are writing that data to our serial port, and then we wait 1 second, and this will just loop infinitely. So every second it's going to be shooting one packet of data containing our packet ID, temperature, pressure, and altitude information. Take a note of what the serial port is right here that we are using. So on my computer, we are using the DevCU USB modem to a 101 port. That'll be necessary information for later on. Everything that I am demoing here is publicly available on our GitHub and it's completely open source. So if there's any part of it where you would just prefer to copy over or clone the entire repository, you're absolutely more than welcome to do that. All the code for the Arduino is hosted right here. All right, now moving on to some of the Cosmos plugin code. Again, all this code is publicly available in our repository. We first start at the plugin.txt. If you follow our documentation, we have a OpenC3 shell script that allows us to generate these plugins and generate sort of the scaffolding around it. So we basically ran those and we're customizing some of the attributes to fit our need for today. So in our plugin.txt file, what we have here is primarily this portion. We have a interface, which is basically how we connect our target, which is our BMP280 sensor, into our Cosmos ecosystem. So that's kind of what allows us to connect through. We'll be using the TCP IP client interface, and I'll go over that a little bit more in detail later. Connecting to our Docker container, and then opening up the 2950 port with a write timeout of 10 seconds and no read timeout. This gets targeted to our BMP280 target. And our protocol for today, I'm going to be using the fixed protocol. We know exactly how long this packet is going to be. We know that it's exactly 13 bytes as we customized earlier. So we're going to use the fixed protocol, and just knowing that we're going to expect exactly 13 bytes per packet of data. Going into the telemetry configurations, we have our telemetry configurations for the status packet is what we're calling this. It's going to be in little endian, as we know that Arduino is going to be natively supporting little endian format. And the 4 items that we have in here, we have the ID, which identifies this packet. We have the temperature, pressure, and altitude readings listed right here. Each are 32 bits, and we have the units also displayed here as Celsius, Pascal, and meters. So in order for Cosmos to actually be able to communicate with our Arduino, we're actually going to have to use a bridge. That'll bridge from the serial connection that we have from the USB Arduino to our computer to a TCP port so that we can communicate to our Docker instance. So we're going to use this shell script that we have here, OpenC3 CLI. It's going to be a bridge gem to use the bridge serial. We're opening up that 2950 port. We're not really writing data right now, so we're keeping that as nil. The read port name is going to be that dev cu USB modem 20101. That's going to depend on your computer. That you can find in the Arduino IDE when you connect to your Arduino. The baud rate we set to 9600, which is the same as what we have in our IDE for Arduino. And we just have no parity here. And we're going to go ahead and run that. And what that'll do is just open up that port and make sure that we have that serial to TCP IP connection. Next, we're going to go ahead and open up Cosmos. The documentation is a wonderful resource to get Cosmos up and running. Check out the Getting Started page on the documentation to get your own installation of Cosmos running. We are going to go ahead and install our new plugin. So we are going to navigate to install a new plugin and drop in that gem file from the Arduino repository. If you'd like to bundle your own gems and create your own after you made your own configurations, check out the documentation on more information on how to build your own gem files. We're going to go ahead and open that. We can verify the data in here. And again, it's that exact same thing that we saw and configured earlier. Once everything's good, we can go ahead and install that. And while it waits, we can go into our command telem server to check out the progress of our interface. And great, it is now connected. What we'll see here is that it was able to connect to our bridge and able to now get information. We'll see this RX bytes and telem packets. Those numbers are steadily rising, which is a great sign that our telemetry is indeed coming through. If we go to a telem packet information here, we can go ahead and hit View in Packet Viewer. And exactly the information we expected, we can see that temperature, pressure, and altitude information rising and kind of fluctuating there. I'm in a pretty comfortable room right here, so the temperature and pressure is pretty stable. But if I go ahead and grab my Arduino right here and kind of raise it and lower it, you will notice that altitude meter will change. this data is going to be much better depicted on our telegrapher here. So we're going to choose the BMP280 target, our packet as the status packet, and the altitude. And we're going to go ahead and add the item. It's going to fluctuate a little bit. This is a very high precision sensor, so we'll see the kind of numbers live change. But if I grab my Arduino here, so as you can see, and gently raise it or lower it, we'll notice that altitude value change as as the sensor picks up on those kind of local changes. Maybe one that's easier to kind of see is if we turn this one off for now, and let's look at the temperature reading. And as I kind of put my hand over the Arduino sensor, we can see that temperature rise. And as I put my hand away, maybe that'll slowly start coming back down. As I kind of just actually, I just put my finger on it. So it's much warmer than just the ambient temperature. And as I put my hand away, it'll probably start cooling. But yeah, it's you can see that every second, all that data is coming through, and we're able to see that live on this telegrapher. And it really makes for a really cool interface. You can kind of imagine how we can communicate with any hardware in the same way. We can communicate with satellites, get that information. We can communicate with any hardware that has any type of telemetry data. So it's definitely not limited to satellites. There's so many use cases for something like this. Telemetry receiving data is only half the game. Sending commands is a whole other battle. With the Telem viewer screen, there's actually a configuration we added to the plugin that sets up a basic screen for us, so we can kind of see the telemetry values of the temperature, the pressure, the altitude coming live from our Arduino. So that was a very quick introduction on the Arduino Sensor Kit and how to connect that to Cosmos. There are many more sensors on this, so I'll be making more videos on integrating the variety of sensors here, and also eventually commanding the Arduino sensor so that we can actually achieve that two-way communication, as well as demonstrating the script runner and all the other functionality that Cosmos has to offer. So please stay tuned. If you have any questions, please feel free to leave it on the video, and we'll see you guys next time. Thanks again for watching.